For our senior design project, our team decided to create a web-connected smart game board that we simply call TheGameBoard. Our main goal was to create a game board platform that would allow the user to play a variety of different board games with the same board and incorporate a web dashboard to allow for user input. We also wanted the web page to show the current state of the board by using smart game pieces that would report their position on the board. For this project, we had a few specifications that we outlined before creating the design. First, we wanted the board to have the dimensions of 50 centimeters by 60 centimeters by 10 centimeters. We also wanted the game pieces to be around 7 centimeters in diameter, which would be small enough to be reasonable for a board game, but large enough to fit the internal components. Next, we wanted the board to draw less than 15 watts of power, and for the game pieces to draw less than 1 watt of power. We've also listed possible clock speeds for the board and the game pieces based on research on common specifications for projects of this type. Finally, we wanted the game board electronics to have a maximum temperature of 85 degrees Celsius so as to not get too hot and prevent components from working. Our motivation behind this project is that we wanted to create a device that would replace people's entire game board collection with a single product. We also wanted this device to guide people through the game but still have a physical aspect to it. The game board consists of 3 main subsystems: the physical board, the game pieces, also known as pucks, and the web server. The board itself consists of a laser-cut 5x5 square wood frame. Inside each of the spaces of the board is a single RGB LED that is a part of an addressable strip of LEDs. These LEDs are controlled by a Raspberry Pi that is housed inside the board and used to light up each space on the board to relay information about the game to the user. The LEDs are connected to the Raspberry Pi through a quad-level shifter which converts a 3.3 volt logic level high of the Pi to the 5 volt logic level high required by the LEDs. On top of each of the spaces is a square piece of acrylic that is used to diffuse the light. On the bottom side of each piece is an RFID tag that stores the location information for each square of the board. Each of the pucks consists of a 3D printed cylindrical housing similar in shape to a hockey puck. Inside of the puck is an ESP8266 web-enabled microcontroller which controls the I/O of the puck. The pucks are powered by a single-cell 750 mAh lithium polymer battery. Connected to the microcontroller is an RFID reader which sits in the bottom of the puck to read the RFID tags in the board, which allows the puck to know its location. When the puck reads an RFID tag, it sends its location wirelessly via WebSockets to the Raspberry Pi. Finally, inside of the puck is an RGB LED which can be used by the games to identify which puck is which by displaying a certain color, or it can light up to let users know whose turn it is. The Raspberry Pi inside of the board hosts an Express.js web server which controls communication between all devices and also contains the logic for each of the games. When the game board is plugged in, the server opens a WebSocket connection between it and the pucks, the web page, and the GPIO client, which allows for two-way communication between the server and the connected clients. By using WebSockets, we can send JSON-encoded strings between each of the devices to allow for seamless communication. The Pi also hosts a front-end web page written using React.js, which displays information about the state of the game and allows for user interaction. When a user opens the web page, they can select which game they would like to play, and then the appropriate game information is displayed. Finally, running on the Pi is a Python script which acts as a GPIO client and controls the LEDs on the board based on WebSockets messages that it receives. To show how our project can be used, we have created 3 games that are playable on the game board: a dice-based game, similar to Sorry, TicTacToe, and a tabletop RPG combat simulator. In this video, we will be demonstrating the latter 2 games. For TicTacToe, the board uses a 3x3 grid in the upper left corner of the board. After the user has selected the game, the pucks light up to let the user know which puck corresponds to which color. The web page lets the players know whose turn it is. Once a player has chosen where they would like to go, they simply place the puck in the corresponding space. The puck's LED will flash to let the player know that it is reading the RFID tag. Once the tag is read and the puck has reported its position, the space will light up with that player's color. The web page will also show what is happening on the board. Once a player has won the game, the web page will inform the players who won and they can reset the board and play again. Next, we will demonstrate the Tabletop RPG Combat Simulator. This game is useful for helping players to visualize combat in games such as D&D. Similar to TicTacToe, once the players have selected the game, the pucks will light up with two colors, red and blue. The players can place their pucks anywhere on the board corresponding to where they are on the map shown on the web page. The players can then choose to make a ranged attack or an area effect attack. These attacks show animations on the board and on the web page. The players can move their pucks at any time to show that their character has moved positions. The web page also allows players to select other maps and to roll virtual dice. A strength of our project is that it is possible to build more games for it in the future. We see the game board as a platform for developers to build games on top of. Also, with multiple game boards, it could be possible for players to play games remotely over the internet but still have physical interaction. Another strength of our project is easy to use because it's simply an extension of how people play board games now. However, our project is not without its weaknesses. For example, for users to select a new game, they must reboot the game board. This is due to how the WebSocket message handlers are set on the server. With some improvements to the software, we believe that this issue could be fixed. Another weakness is that the pucks can be prone to disconnecting from the internet. This is due to the weak wireless radio of the ESP8266. As long as users stay close to a wireless access point, this issue is not too big of a problem. While working on this project, we did run into a few issues. Most notably, we ran into a problem where the pucks would brown out when trying to send WebSocket messages to the web server. We determined that this was due to the CR2032 batteries that we were initially using to power the pucks not being able to provide enough power during communication. We were able to solve this issue by replacing the coin cell batteries with relatively large LiPo batteries that could handle higher power draw. From this project, our group members were able to not only use the knowledge that we have gained from the ECE courses we've taken at Clemson, but also manufacturing techniques, project design, project management, and how to work as a team to complete a common goal. We believe that these are valuable skills that we will use in our future careers in engineering. This concludes the technical review of our project. Thank you for watching.